If you look at the solar system, our little quiet neighborhood in the galaxy, it feels safe. It feels engineered. The planets move like clockwork gears. The Earth sits at the perfect distance from the Sun. The gas giants like Jupiter stay far away, acting as silent guardians against asteroids. It gives us a sense of order. It makes us believe that physics follows a strict, polite set of rules and that the universe is a predictable machine. But that is a lie. When astronomers point their telescopes into the deep black, looking past the comfort of our own sun, they don't find order. They find chaos. They find a universe that is messy, violent, and creatively insane. We are discovering worlds that defy every model of formation we have. Planets that are too hot to exist, too heavy to stand, too fast to form, or too lonely to survive. And yet, or against all logic, there they are. Today, we are journeying to the edge of scientific understanding. We are not just looking at planets, we are looking at the cosmic rebels. These are 10 specific types of worlds that are currently forcing scientists to rewrite the textbooks on how the universe actually works. They serve as a humble reminder that our understanding of the cosmos is still in its infancy and that out there in the dark, the impossible happens every single day. Let's begin with the rebels that live in the fire. For decades, the standard model of planetary science was simple and elegant. Rocky planets form close to the star where it is hot, and gas giants form far away in the cold, icy outer reaches. It makes sense. Gas needs cold temperatures to condense and clump together. A gas giant shouldn't be able to exist right next to a star. But then, the universe threw us a curveball with the discovery of the hot Jupiters. Imagine a planet with the mass of Jupiter, huge, gaseous, immense, but it is not sitting in the outer freezing zones. Instead, it is hugging its star, orbiting closer than Mercury does to our Sun. These worlds are a paradox. Technically, they shouldn't survive. The radiation pressure at this distance is like a continuous nuclear blast. The temperatures soar above 4,000 degrees Fahrenheit. Take, for example, the nightmare world of WASP-76b. On this hot Jupiter, the heat is so intense that it vaporizes iron on the day side. The planet is tidally locked, meaning one side always faces the star and the other faces the void. Winds scream around the planet at thousands of miles per hour, carrying that vaporized iron to the cooler night side, where it condenses and falls as liquid iron rain. But the real mystery isn't their weather, it's their location. How does a gas giant get there? The leading theory is planetary migration. These giants were likely born in the cold, safe outer lands, but through violent gravitational interactions with other planets or the protoplanetary disk, they were dragged inward. They are travelers. They crossed the danger zone, spiraling toward their own destruction, and somehow, they stopped. Just before falling into the star, they stabilized. They are the survivors of a cosmic game of chicken, living on the razor's edge of incineration. But if hot Jupiters are survivors, this next class consists of the daredevils, planets found in the evaporation zone. Unlike the gas giants, these are often rocky cores, stripped bare. Physics tells us that inside a certain radius, known as the dust sublimation zone, it is physically impossible for a planet to form. The heat is so high that dust grains cannot stick together to build a world. They should just vaporize into gas. Yet, we see planets here. Astronomers call these Chthonian planets, named after the Greek deities of the infernal underworld. They are likely the skeletal remains of gas giants that ventured too close. The star's intense radiation stripped away their thick atmospheres, peeling them like an orange, layer by layer, until only the dense, rocky, molten core remained. They are planetary corpses that refuse to disappear, orbiting their killer in a loop of eternal defiance. They remind us that destruction and creation are often the same process in space. Let's move away from heat and talk about density, the very structure of matter itself. In our solar system, density is predictable. Rocks are heavy, gas is light. We understand the limits of how much matter you can pack into a certain space. But out in the galaxy, we have discovered the ultra-dense heavyweights. Consider a planet like Kepler 131c. It has a radius similar to Earth's, maybe slightly larger, but its mass is exponentially higher. Imagine a world where the gravity is so crushing that if you stood on the surface, your own blood would struggle to pump to your brain. Your bones would shatter instantly under your own weight. These planets challenge the structural limits of matter. How do you pack that much mass into such a small volume without the planet collapsing into a black hole or igniting into a star? Some theories suggest these are the result of massive cosmic collisions, two giant planets smashing together at high speed, stripping away the light mantle and fusing their heavy iron cores into a single super-dense ball bearing in space. They are unstable monsters, held together by forces we are still trying to model, proving that matter can be compressed far beyond what we experience on Earth. While some planets are too heavy, others are simply too fast. I'm not talking about orbital speed, I'm talking about birth. This is the mystery of the rapidly formed giants. Building a planet like Jupiter is supposed to be a slow process. It's called core accretion. You need millions of years to gather dust, build a rock, and then slowly suck in gas to create a thick atmosphere. It is a slow, graceful construction project that takes time. But we have found massive, Jupiter-sized planets orbiting stars that are effectively newborns, stars that are only 2 or 3 million years old. Mathematically, there hasn't been enough time for these planets to grow. It's like walking into a nursery and finding a fully grown adult sitting in the crib. It doesn't fit the timeline. This suggests a terrifying alternative way to build a planet: disk instability. The idea that the cloud of dust around a star doesn't build up slowly, but rather collapses violently and instantly due to gravity. One moment there is dust, the next, a planet. It's a violent, sudden birth that changes our understanding of how quickly a solar system can come online. It implies that planet formation isn't always a gentle evolution. Sometimes it is an explosion of creation. And then, there is the question of composition. What are these worlds made of? Earth is a silicate world, made mostly of oxygen and silicon sand. But the universe is a chef with many ingredients. If a star system is born with too much carbon and not enough oxygen, you don't get rocks. You get diamond planets. This isn't science fiction. Consider the world of 55 Cancri A. In a carbon-rich environment, heat and pressure transform the planet's crust. We aren't talking about a few diamond mines. We are talking about continents made of graphite, mountains made of diamond, and bedrock made of crystalline carbon. But before you imagine a treasure hunter's paradise, remember the reality of these places. These worlds are often scorching hot or incredibly alien. A diamond planet isn't a jewelry store. It's a hostile, alien landscape where the very ground you walk on is harder than anything found on Earth. The thermal conductivity of diamond is different from rock, meaning the way the planet handles heat, volcanoes, and tectonics would be completely alien to a geologist. It is a world of luxury materials, but a landscape of absolute desolation. Now let's look at the dance of the heavens. We are used to one sun. It rises, it sets. Simple. But nature seems to get bored with simplicity. Enter the circumbinary planets, worlds that orbit 2 stars at once. For a long time, astrophysicists thought these Tatooine worlds were impossible. The gravitational war between 2 stars should effectively play ping-pong with any planet trying to form. The chaotic gravity should tear the dust apart or fling the planet out into deep space before it can settle. Yet, we keep finding them. Kepler 16b was the first confirmed example. These planets have found a gravitational sweet spot, a delicate, stable path woven through the chaos. But life there would be strange. Your shadow would split in 2. The concept of day would change constantly depending on which star is in the sky. Sometimes you would have 2 sunrises, sometimes the suns would eclipse each other. It is a world of constant visual duality, proving that order can emerge from a tug of war. It highlights nature's preference for complex, intricate dances over simple, circular paths. If 2 suns aren't chaotic enough, how about a world that doesn't know which way is up? Let's talk about extreme axial tilts. Earth tilts at a comfortable 23 degrees. This gives us our seasons. Summer is warm, winter is cold. It is a gentle cycle. But imagine a planet tilted at 90 degrees. It doesn't spin like a top. It rolls like a barrel along its orbit. The consequences are terrifying. On such a world, the North Pole points directly at the sun for the entire duration of summer. If the year is long, you could have a day that lasts for decades, roasting the surface, while the South Pole is locked in a decades-long night of absolute freezing darkness. When the seasons finally change, the shift is cataclysmic. Winds of unimaginable speed would rush from the hot side to the cold side to balance the atmosphere. These are the cosmic thrill seekers, worlds where the weather isn't just a topic of conversation. It's a daily apocalypse. The existence of these tilted worlds suggests violent histories, ancient collisions that knocked the planet over, and leaving it to spin wildly through the ages. Sometimes the chaos isn't about the planet itself, but the neighborhood. We are finding systems packed with super-Earths in extreme resonance. In our solar system, planets are spaced out comfortably. We have room to breathe. But in systems like TRAPPIST-1, nature has crammed 7 rocky planets into a space smaller than Mercury's orbit. They are packed together like passengers in a crowded elevator. They should crash. Gravity should destabilize them, but they survive through resonance. This is a cosmic rhythm. For every 8 times one planet orbits, the next one orbits exactly 5 times, and the next exactly 3. They are locked in a mathematical dance, tugging on each other just enough to stay stable. It's not silence, it's music. If you stood on the surface of one of these worlds, and the neighboring planets wouldn't look like dots of light, they would look like huge moons, looming overhead, whizzing by in a crowded sky. It shows us that chaos and order can coexist in a delicate harmony. So far, we've looked at planets that survive fire, gravity, and chaos. But now we must look at the planets that survive death. When a massive star dies, it doesn't go quietly. It explodes in a supernova, a blast so powerful it outshines the galaxy. Any planets nearby should be vaporized instantly. But incredibly, we have found pulsar planets, the zombie worlds. These were actually the very first exoplanets ever discovered, orbiting a pulsar, the rapidly spinning, dead core of a star. These planets are bathed in beams of lethal radiation that sweep across them like a lighthouse beam of death. Where did they come from? Did they survive the explosion? That seems impossible. Or did they form afterwards, assembling themselves from the debris and dust of the dead star? We call them zombies because they orbit a corpse. They exist in a stellar graveyard, enduring conditions that would strip the atmosphere off Earth in seconds. They are a haunting reminder that the universe recycles everything, even the dead. They prove that planetary formation is so robust, so stubborn, that it can happen even in the aftermath of the greatest explosions in the universe. And finally, we reach the most unsettling category of all. The worlds that defy the most basic rule of planetary existence. You need a star. These are the rogue planets, the wanderers. Current simulations suggest that for every star in our galaxy, there might be dozens of these rogue worlds floating in the dark space between systems. They are orphans, likely kicked out of their home solar systems billions of years ago by a gravitational accident. Drifting in the interstellar void, they have no sun, no sunrise, no sunset, just eternal crushing darkness. Their surfaces are frozen solid, nearing absolute zero. But here is the twist that keeps astrobiologists awake at night. They might not be dead. If a rogue planet has a thick atmosphere and a hot, radioactive core, it could trap its internal heat. Beneath miles of frozen ice, there could be liquid oceans, warm, dark water protected from the void. In that eternal blackness, life could theoretically exist, swimming in a sunless sea, completely unaware that the rest of the universe even exists. They wouldn't know what a star is. No, they wouldn't know what light is. They are out there right now, silent, invisible, passing through the shadows of our own solar system, unseen. They challenge our deepest belief that a planet needs a star to exist. We used to look at the sky and see a clockwork mechanism. We thought we were the standard. We thought Earth was the rule. But these 10 types of worlds, the migrants, the zombies, the speed demons, and the orphans, they tell a different story. They tell us that our solar system is actually the exception. We are the odd ones because we are so calm. The universe is not a machine. It is a wild, untamed wilderness. It tries every possibility, no matter how extreme. It breaks its own rules just to see what happens, and while that reality is chaotic and perhaps a little terrifying, it is also undeniably beautiful. It means that the possibilities for what is out there are truly infinite. So the next time you look up at the night sky, remember, the quiet is an illusion. Out there in the deep dark, the rebels are dancing.